Whether it's Facebook or Google ads, Instagram or Twitter feeds, YouTube or Netflix recommendations, much of the content we see is specifically curated for us. Due to the abundance of media over the internet, different platforms compete to provide customers with customized content in order to gain the user's attention, time, and even data. This benefits companies and it benefits us, the users, in being provided with what we actually want to watch. But how do companies actually figure out our preferences? Well, the answer lies in artificial intelligence and machine learning and algorithms that are able to detect patterns from our activities. We can even tell YouTube that we don't want to see certain recommended videos because we just don't like them, and we probably won't see things like that again. But in order to understand how this actually works, we must begin with an introduction to the development of artificial intelligence. So, what exactly is artificial intelligence? More than half a century ago, artificial intelligence was a term coined for a concept that was ahead of its time. It was first used in 1956 by Dartmouth professor John McCarthy, who called together a group of computer scientists and mathematicians to see if machines could learn like young children and used trial and error methods. Their project proposal claimed to figure out how to make machines use language, form abstractions and concepts, solve problems only humans are thought to be able to tackle, and eventually learn to develop themselves. Nowadays, the field of artificial intelligence has become much more advanced and has numerous existing applications and possible implications. So how can we simply understand such a complex and diverse field? I think the best way to think about artificial intelligence is in the context of a human. After all, when the term was first coined, the purpose of AI was to teach machines the things humans can do and more. So here is John. John is a student. At 7 a.m., his mother yells from the kitchen telling him to wake up and eat breakfast. Although John wishes to block out his ears for an extra 5 minutes of sleep, or 30 minutes, or more, he cannot magically shut down his ears to block the irritatingly loud speech of his mother. And since his main function as a student is to go to school, he grudgingly gets out of bed and walks downstairs to the kitchen. In the field of AI, this would be like speech recognition. Just like John, the virtual assistant we all know, Alexa, may be irritated by the constant, "Hey Alexa, hey Alexa, hey Alexa," and "Hey Alexa, play Despacito." But she must always be listening for human voices to recognize their speech and to do whatever task they assign, because that is her job. When John gets to school, he has to write and read for his English class. In the field of AI, this task would be imitated through natural language processing. John can also see the world with his eyes, and this is the field of computer vision for AI. Lastly, John can see patterns through observations. This is related to the field of pattern recognition in AI, which we'll continue to talk about because it is one of the most basic and important skills of machine learning. Unfortunately, or maybe fortunately, the machine can beat John in certain tasks in terms of speed, efficiency, and accuracy. For instance, in recognizing different patterns, a machine processes much more data at a much faster speed than John can, which is partially why machine learning has become such a hot topic in the field of AI. Think about the regressions you needed to do for all your statistics classes. A machine can do it much better in some sense. For example, if you have lots of data for college students' GPA and their respective graduation salaries, and you plot them on a graph, you may be able to see a pattern. But machines can do much more. Beyond that, a machine can learn this pattern and actually make predictions on what it has learned. While an average human can maybe understand the data in 1, 2, or 3 dimensions, a machine can work with thousands of dimensions and make predictions that humans cannot come close to understanding. Then, the next question to ask is, how have humans been able to build things that are too complex for even humans to understand? Well, a few decades ago, humans used to build algorithmic bots by giving them instructions that humans could explain. However, as the tasks became more complicated, it became more difficult for humans to write instructions. So now we write instructions to make the bots teach themselves. Say that you wanted to build a bot that can differentiate between a cat and a dog. We cannot simply give the bot instructions and code on how to do it because machines do not understand the world as we humans do. It would be like asking a human to do different tasks through computer programs. It is just not feasible or economical. Therefore, we build bots that build other bots and bots that teaches bots, which is not as difficult to program. The process begins with the builder bots building student bots, which are trained by the teacher bots. While the teacher bot also cannot tell a cat from a dog, because if it could, we could just solve the problem directly. The teacher bot is given many photos of dogs and many photos of cats and an answer key to which is what by us humans. Then the teacher bot gives tests to the bots. Of course, the bots will fail terribly at the tests because they have no previous learning experience for the task. The bots get sent back to the builder bots, and the builder bots separate the bots who do well in the tests and those who do badly. The builder bot smashes the bad bots into pieces and builds new bots that function similarly to the good bots. When these new sets of student bots are assembled, off they go to the new tests. Some survive again, and some don't, and new bots similar to the even better bots are built again. The loop repeats itself until the bots can pass a certain level of accuracy. Now, the builder bot has a sample of bots that it can replicate, and voila, there is a group of bots who can do fairly well on the task. However, no one understands how the bots really function. Not the builder bot, nor the teacher bot, and not even the humans, because the brains of the bots are so complicated after such a large number of changes made by the builder bot who is not smart enough to keep track of everything. The bots themselves probably don't even understand how they do what they do. Nevertheless, we have a group of bots who can now identify the cats from the dogs. Mission accomplished. However, as great as the bots are, they can only learn to perform one single task at a time, at least for now. Some changes, such as using a video of cats instead of pictures, or switching the dog pictures to dolphin pictures, means that the bots have to learn from scratch. This problem has led to the development of the concept of general artificial intelligence. General artificial intelligence is the intelligence of a machine that could successfully perform any intellectual task that a human being can. Maybe, in time, a real-life Terminator could be made possible with the general artificial intelligence. But meanwhile, major developments such as self-driving cars that have the potential of replacing human drivers, and Elon Musk's OpenAI that trains robots to potentially carry out different tasks in factories are preparing to change our lives dramatically.